So let's finish it ASAP. I'm actually hungry. I only ate breakfast, and after breakfast, haven't ate anything yet. Hungry for some knowledge. Okay, so let's start with a question someone asked me yesterday. So while I was doing this question, hopefully you were here yesterday, so you know what we did. So while I was doing this question, someone asked me if I can use method 1 and show you how do we use method 1. So again, so I'm gonna repeat those 3 tips because the reason I repeat them is because they don't always work. Okay, it's not like, oh, if you're given a question, then any of the 3 will work, will give you the answer. That's not true. Okay, those are just some tips I'm offering you. So sometimes you might need to use the first method, sometimes you might need to use the second one, sometimes you might need to use a third one, and sometimes they might not work, and you need to come up with a new solution. So also yesterday someone was stuck on one of the problem set questions for a while, and I provided them a new question. So I'm gonna use the question I gave to them to demonstrate how do we use the first tip I gave to you. Okay, so I think I wrote it down here. So here is an extra question. This function is defined from natural number, Cartesian product natural number, to real number, and it's defined by this, which is what you should know from the problem set. So the problem set asks you to show that the image of this function is contained in natural number, which means, well, you need to show the image is a subset of natural number, which is simple. It's like a 2-line proof. Now, I'm asking you to find an element from natural number which is not in the image of F, and I want you to justify your answer. Again, this question is not hard. It's not hard at all. To find an element, it's not hard at all. So something that might be slightly tricky is to prove whatever element you claim to not be in the image is indeed not in the image. So what do we do when we see something like this? So this is where I would transcription be unable, okay? So this is where I would say the first tip is quite useful. So I'm gonna compute some of the image and see what they look like. So for example, since they are natural cross natural, I'm gonna start with 1, 1. So let's see. Again, this is your rough work, okay, rough work. So let's see, f of 1, 1 looks like what? Looks like a plus 1, oops, 1 plus 1. 1 plus 1 times 1 plus 2 over 2, which is 3. Okay, and the next one you can try the next, for example, 1, 2 will give you again 1 plus 1, and you have 1 plus 2 times 2, which is 4 over 2, which is gonna be 5. And you can also compute 2, 1, which is gonna be 1 plus 1 times 1 plus, sorry, it's not 1 plus 1 anymore, it's 1 plus 2, I mean 2 plus 1 times 2 plus, sorry, my bad, 2 plus 2 over 2. So this is 4 over 2, that's 2, 2 times 3 is 6, and so on. So if you do this, okay, one of the observation is I see that this is actually going up, it's increasing. So observation is f is an increasing function. What does that mean? It means, well, you'll never get a number that's smaller than 3. right? And as your x and not x and y, as your a and b get larger, your output is going to get larger. So you cannot map to, this is 5, 6. So you cannot map to 4 either. Do you see? So in this way, we're using the first tip I gave to you, and we figure out that, well, there are some values that you can never get to. Well, which one would I pick to do my proof? I usually pick the smallest number you can get, or the easiest one you can get. So if I have 0, I pick 0. This is all rough work, yeah. 2 is 15 over 2? What? Are you sure? I'm pretty sure they're all mapped to integer, natural numbers. Okay, so this is rough work, yeah. So as I said, we have many numbers you can never map to. For example, from here I know that 1, 2, 4, they are not in the image. And which one would I pick? I would pick 1. If I have 0, I will pick 0. Right? Because you pick the smallest one, it's going to be easier for you to justify your answer later. So I'm going to pick 1 as my element, and I'll show you a proof. So let me use another color. So here is my claim. So again, I'm going to claim that 1 is not in the image. It's not in the image of F. Okay? So now I'm gonna say if 1 is in the image, then I would have f of AB equals to 1. Right? Which means what? Which means this, which means this whole thing, which means A plus 1 times A plus 2B over 2 equals to 1. In other words, A plus 1 times A plus 2B equals to 2. Now, from this, can you get something to show that 1 is not in the image? Anyone has any idea? A plus 1 is greater than or equal to 2. Why? Because A is greater than or equal to 1. Okay, and what? And then do the other side. Okay. So I'm gonna say this. It's similar to what you said. I'm gonna say this. Since we can definitely use your argument. So since A is a natural number, which means A is greater than or equal to 1, this leads that A plus 1 is greater than or equal to 2. Also, since A plus 2B is a natural number, okay? What do we say? And A plus 1 has to be a natural number as well. We can only have, because you have 2 natural numbers multiplied together and equal to 2. One of them has to be greater than or equal to 2, which means this one can only be 2 and this one can only be 1. We can only have A plus 1 equals to 2 and A plus 2B equals to 1. And now you can solve for this. So in this case, this is 1, this is 2. So from 1, we have A equals to 1. We can sub into 2. You have 1 plus 2b equals to 1, which means 2b equals to 0 and b equals to 0. This is not a natural number. Okay, so since A is 1, so 1, 0 is not in natural cross natural. We can say 1 is not in the image. Okay. Also, so there are many ways to do this. Also, starting from here, we can use your argument as well. So you can also with what you said. So we can let me write it here. So you can do this. You can also do this is only 2 times 1 or 1 times 2, and make this, make this 1, make this 2, or make this 2, make this 1. You will also reach that AB is not natural cross natural. You can also use one of your arguments, use another color. You can also say, oh, A plus 2B. You should not do that directly. You can also say B is greater than or equal to 1, so 2B is greater than or equal to 2, so A plus 2B. So you're adding this one and this one together. That's greater than or equal to 3. And your product is never gonna be 2. So you can also use that argument. So A plus 1 times A plus 2B is greater than or equal to 6, which is not 2. So there are many ways to do it. Okay. The thing is, that's exactly what I wrote here. So again, there are many ways to do this. But what I do want to show you is this part. Okay, so here is what I do want to show you. The observation from your rough work is more important than this, because this is quite simple. This is quite simple, but this is what I want to show you. Okay, any question for this one? So this is the first question someone asked me yesterday. After this, we'll do the second question someone asked me yesterday. How did you get the piecewise again? There is no piecewise. This is a system of equation. It's not piecewise function. Yeah, it's a system of equations. Okay, if no, I'm gonna answer. Yeah, I added this one and this one together because both sides are positive. We can just do it. We can just add them together. Okay. If no question, let me answer the second question someone asked me yesterday. Again, it's from this question. I know we'll never get rid of this question. The second question someone asked me is, what if the question asked me to find the image of this function? Okay, and then prove it. I'm gonna say for 2 variable functions, asking you to find the image directly is kind of too hard for you because you've never learned that before. So that's very unlikely to be there. However, they can give you an image and then they ask you to prove it. That's possible. Okay, asking you to find the image is quite hard, but they can give you the image of the function and ask you the image is indeed the image. That's possible. I do not have a specific example. So example 2. Example this one? No, this one's simple. Not simple. I mean, this one has only one variable and it's not mapping to anything weird either. So not this one. Yeah. So I'm talking about Cartesian product questions. Okay. It's possible that they give you an image and ask you to prove it. I think the first direction should be simple. But the second direction might be hard for you. So for example, the first direction would just be, you know, for example, proving this is a subset of an, you know, which is simple. Pretty sure all of you can do it. However, backwards proof is not that easy, and I don't really have a example. So I'm gonna use this one and make something up. Okay. Again, this is made up. I'm not saying the image it is something. So I'm just gonna show you roughly how you do it. It's similar to when you have one variable. So again, let's use this function, and let's say this is from, was it from natural to natural? Map to, let's say map to integers. Oops, integer cross integer. Okay, so I'm gonna say we have this, and let's say they gave you the image. So let's say image is, again, this is not the image of this function, okay? Let's say image is, I'm just writing something random. So let's say it's I don't know, m plus 2 and 2m. Again, I just made it up. It's not something, it's not actually the function. I should write it here. This is not really the image of the function. Just show you how to do it. This is not the image of G. Okay, it's not. However, I can use it to show you how would you deal with this. So you need to do some rough work. And the rough work, how do we do this, is pretty similar to what we have before. Actually, using this one might be too hard. Let me think. Yeah, it might be too hard. Let me change the question. I feel like that might be too hard. Let me use f as defined as f of a equals to a. What do I want it to be? Give me a moment. Let me think. I wanna map to a Cartesian product like this. Maybe this will be easier. Not a. A is too simple. Let's map a to be. Okay, what do I want it to be? Okay, this is causing me too much trouble. We'll just use the original question. Because for me, it's too hard to think of an example. So rough work you need to do is, if they say this is an image, or if they ask you to prove, so they ask you to prove this is, well, I don't know, M is this. Okay, for example, it's not the image. They ask you to prove this is in this, is in the image. What you need to do is you do rough work, just like what we did before. You do rough work and you use tip 3. Tip 3, okay? Which means you let it equal to something. What do you let it equal to? Again, this is rough work, okay? Rough work. It's not the proof. So what do you let it equal to? You let them equal to this, to whatever you need to prove. So you let this be this, and you let this be this. So you have a system equation again. You have 3x plus y is m plus 2, and you have x minus y is 2m. Again, this is just demonstration. This is not the image, okay? So we're just doing this. And what you need to do is you need to isolate your x and y and see what they look like. So, okay, I'm not gonna do this step. Just I'm just gonna say isolate isolate x and y. Okay, then whenever you isolate it, the x and y in terms of m, right? It's gonna be in terms of m. In terms of m would be the xy you sub into your g. Okay, does that make sense to you? So this is how we do rough work if you have two variables. I'm not sure if this makes sense to you. So it's similar to what we had before. How do we isolate? You solve the system equation. You add them together. Right? You add them together, you get 4x equals to 3m plus 2. Then x is this over 4. You see? And you sub into one of the equations. Like mini algebra, like high school. I'm pretty sure these sound things similar in high school. Find the image is way too hard for you guys. You need to learn multivariable calculus first. So I don't think we'll ever ask you to find the image because you guys only know one variable calculus. Once you learn multivariable calculus, you can find the image. Yeah, so I think most likely they will give you an image and ask you to prove. This is a fair game. Yeah, this is a fair game. So they give you something and ask you to prove it's okay. But ask you to find it, that's too hard for you guys. So that's not a fair game, but this is a fair game. So they give you an image and ask you to prove it is indeed the image, then it's not bad. Okay? So it's the same, just the same as before. So just the let me go to this part and then I'll go to the tips, okay? So it's just the same as before. You do rough work. Say you're using rough work, find your x. In just the only difference is now you don't just have x, you have xy, right? You have a pair. So that's the only difference. And I told you how would you do the rough work. So if they test you on that, hopefully you know how to do them. Just need to do some rough work and then plug it back in. Okay? Now go to the tips. And now I wanna add another tip because I forgot about it yesterday. Now I remember. Sometimes it's really helpful to fix one of the variables. Sometimes it's helpful to fix one variables. What do I mean by that? So you have two variables, they both change. Sometimes you can just fix one of them. For example, I let this be 1. Okay, it's not helpful here, but sometimes it's helpful. So you fix one of them, then you deal with the other one. Are you okay now? Can I move on? Okay, so I want to show you one example for this one, and then we'll do other questions. So this one will be the question that they gave in my last semester's tutorial. Might be this one, let me see. Oh, sorry about your eyes. I didn't use dark. Here, so this one. Okay, if you did my 28 questions, you probably have met this one already. So this question is when you fix one of them, it will be really helpful. So the first part is really easy. So let's look at the second part. So this is my function, and they want you to prove the image of G equals to 0 union natural numbers. So first direction, really simple. Don't need to look at this. Second direction. So I picked to be in this, right? And then now I need to find my x and y. So what I meant by fixing one is really helpful. I can fix my y to be 1. Okay, so for example, I fix my y to be 1. So I have this. I have this, and I want it to be now you can solve for this. Since they are, this is in, n is in this. Okay, remember n is in 0, union natural. So it's non-negative, so you can get rid of this. So that's going to be x minus 1 equals to n. So you know that your x needs to be n plus 1. Do you see? So in this case, fixing one of the variable will be really helpful for you. So this is an example of tip 4. I forgot about this yesterday, and yesterday someone was doing this, and that reminded me, or today someone was doing this, and reminded me that I forgot to give you this tip. Does this make sense? Is there a specific reason why I chose 1 as the number? Oh, as I mentioned, I always choose the smallest number or the easiest number. That's why I chose it. But for this question specifically, there is a reason, because x equals to n plus 1, okay, will guarantee your x to be natural number. Because your n could be 0 and 0 plus 1 is natural number. You don't have to pick 1, pick 2, it works too. Pick 2, so it's n plus 2 and 2. Well, both of them are natural numbers, so it works as well. But I really like to pick the smallest one, so to make my life easier. Yeah. What would indicate that fixing a variable might help? I think a lot of functions I saw, if it look like this, so it maps from a Cartesian product to a single value. A lot of time it's helpful. What if we have functions that return multiple values with absolute values? Oh, you mean like this? Like this? And then you have, let's say this. Like this? Yeah. Well, in that case, you need to combine the ones with absolute value and the one with multivariables, which is gonna be pretty bad. They will be really mean to give you something like that, to be honest. When we take cases, you do lots of rough work. So rough work is your friend in that case. I'm sorry. I'm going to have a panic attack if I see that type of questions. I don't think they are that mean. I really don't think they are that mean. But something I talked about so far, I think those are all fair games. You know what I mean? Those are all fair games. Like something like this is definitely fair game. Something I just talked about, you know, like this question, definitely fair game. This question, definitely fair game. Okay, so those are definitely good. As long as we pick a number within the domain, it's fine for fixing any number, right? Well, you need to make sure. So as I mentioned, there are 2 conditions you need to satisfy, right? The first is, okay. The first is whatever you picked is in the domain. And the second is if you plug it back in your function, you'll get back to whatever you picked in your codomain. Or not codomain, I mean image. So as long as you satisfy those 2 conditions, you're good. But it's not gonna be an example, so you're not gonna fix both of your variables, you know, because that's gonna map to a number, right? Not your y or not your n, because it's like n is any of the natural number union 0 for that example specifically. So it's not gonna be a number like 2 or something like that. Okay, any other question before I move on to example 2? So those are the 2 questions students asked me. So hopefully I answered your question detail. Can we get 4 minutes to solve it? Oh, sure, why not? I'll give you 5 minutes. don't think you can solve it in 5 minutes, but I'll give you 5 minutes. Okay? But if you have no question, you can start trying this one. If you have question, ask now. We'll take it about 5:45. Can I send it over for me to look over? I don't want to check your solution. I'm not a big fan of proofreading other people's solution, to be honest. You can do that on Piazza and ask other people to check, but I don't like it. It's like marking for me, except I don't give you a mark. Why does sunset before 6? I feel like I need to sleep. I want to eat. I'm hungry. I'm not sleepy because I'm drinking my coffee, but I'm hungry, really hungry. Anxiety. Hopefully you're not too anxious about this. I keep getting emails from students saying that they have a headache because of the course, either this course or the other course I'm teaching. Sounds really bad. Is it that stressful for you guys? I feel like so far we're being pretty nice. I think I'm being pretty nice. Can't say it for other people, but I think I'm being pretty nice to you guys. Sure. If you don't wanna accept something and just think it's not real. Thank you. 1 more minute, okay? 1 more minute. And we'll take it up. Try it first. If I see a chat time, I'll also buy bubble tea. I should stop being so addicted to bubble tea. I'm trying to not doing that, but it's kind of hard. Okay, let's try this taro milk tea. I think I just had taro tea latte today with no sugar. I don't like sugar, but bubble tea is good. I also don't like milk tea that much because I don't like the powder they use. So I usually get tea latte. So they use real milk. But you like fruity? Yeah, I like fruity with no sugar. So for me, it's like no sugar, no ice, and no powder. Yeah, back to this. That sounds like tea. Well, you add milk to it. Tea latte, right? Tea latte. Latte, milk. I like tea latte. Anyway, back to this. A few tips I'm gonna give to you again. Few tips. When you see absolute values, okay, my tips for you. You get rid of them first. 90% of the time, you need to get rid of them. So get rid of your absolute value. Get rid of your absolute value first. Because they are annoying. They are annoying for everyone. How do we do that? There are many ways to do that. So the first way you can do is you write it as a piecewise function. Write it as piecewise function. Another way to do it, not like this time, it's not like getting rid of it, is you recall that absolute value of x is actually square root of x squared. Okay, this way is trying to, if you think, okay, you use this if you think you can solve the question using AGM. Use this if you want to use AGM or something like that. If you want to use AGM. Okay, and the third way, this time it's not getting rid of it anymore, but it's helpful, is use triangle inequality. Okay, so those three things is what usually pops up in my mind when I see absolute value. First way is always helpful because you can do that in calculus courses as well, write it as a piecewise function. Like, well, for example, let me give you an example. If you see absolute value in your integral, something like this. If they ask you, okay, calculus example for the first one, calc example. What do I want? What do I want, guys? Displacement function. Find displacement. It has absolute value in there, right? Do you guys know that or no? Or should I not do this? That works. Do you know displacement and distance? Okay, let's not use this. For example, integral -3 to what do I want? X squared minus absolute value of x squared minus, what do I want it to be? 3x. For example, okay. dx. Is this a good example? Let me check. So x minus 3. Oh, that's 3. I want it to be 2. No, I want it to be 1, 0. Might be too complicated. Let's use 2 then. Minus 2x. Okay, so in this case, we want to, you need to check 1 is greater than 0 or less than 0. So like you need to draw this, and you see 1 is greater than or equal to 0. So if it's less than 0, it's negative, so it's positive, negative, positive. So it's greater than or equal to 0 when it's in between, it's less than 0 or greater than 2. Which means you need to write it as sum of 2. Sorry that I'm teaching calculus. I apologize for that. I don't feel like I'm doing the right thing right now. But just want to show you an example to see how helpful it is. And then write it as 0 to 2. Yeah. And then from 0 to 2 is negative, so it's 2x minus x squared dx. Right. So in this case, you can get rid of the absolute value, and it's really helpful. So in this case, it's not a piecewise function. So I'm saying you can write it as a piecewise function. You know, is x squared minus 2x when x is blah, 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 blah. And it's 2x minus x squared when it's blah, 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 blah. So it's really helpful. In everywhere, in 102, in calculus, everywhere. It's really helpful to do the first one. And the second one, it's really helpful. Like, for example, you've seen it before. Example as your problem set. B, question 4. Right, you write it as square root of a square. Really helpful. Third one, triangle inequality. What's wrong? Are you hungry? Oh, we're not doing integrals. I'm just trying to show you absolute values. What to deal with them, how to deal with them. Triangle inequality. Okay, when do you use this? When you see this and this. Okay, so the third one is really helpful when you see both of them in your question. Now, get back to this question, okay? Again, rough work. Let's do the first direction first. So I wanna find the image and proof. Okay, I don't need to find the image first. I just use my first direction to find the image. So I want to show f of r is a subset of something. I don't know yet. We'll figure that out later. And now I wanna do what? I wanna show this is in between an interval. Now my question is 1, 2, 3. Which one do you think is gonna be helpful for this function? And why is that? For the first direction, okay? So I'm trying to find the image. It looks like triangle inequality. Why? Do you see this? Do you see this and this? Yes, where is that? Well, I do see this, but where is this plus 4? Tell me where is that? Yes, it's 3 times that, right? So we can first write this. Notice that this is equivalent to this. Oops, sorry, my bad. So it's 3, no, sorry, not 3. Yes, 3, my bad. 3 times absolute value of x plus 4. So in this case, I have a plus absolute value of a plus b. I also have absolute value of a plus absolute value of b. So which means triangle inequality is our friend. Okay, do you see why we're using triangle inequalities now? Yes, okay. So now, by triangle inequality, I know that, well, this is greater than or equal to 0. This is clear. This is also less than or equal to this. right? And now I have this inequality. I want to reach inequality for this. How can I get from this to this? I need to divide all three directions by this, since this is positive. So this is rough work, not proof, so it doesn't matter. So from this, I know that just divide by that. Divide by 3 times this. Right? And the other direction should do the same thing. So this is still 0. This side would be this. 3 times. Oops, this is not 12, this is 4. I keep making typos, I don't know why. I'm too hungry now. I need food. Okay, so this is what I have. Again, this is rough work. And those two cancel out. So this is the same as 1/3. So ta-da! We got our image. So we know that this is in between 0 and 1/3. So we're done. Okay, so that's first direction. My rough work for first direction. So now I know that, oh, image is this. And this is the first direction. Now, that's my rough work for first direction. I'm basically done. Rough work for second direction. How do you even see that on a test? Didn't I just told you? Didn't I just told you how do I get it? I told you I see this and I see this, so I know it's triangle inequality. So I start with triangle inequality. I see I just need to divide all 3 sides by this. So I just divide it. Done. I just told you my thinking process. Okay. Now, second direction. Remember what do I need to show? I want to not show, find x from real number such that f of x equals to y for all y in real number. Okay, so basically you need to do rough work. So do rough work, which is what we're doing now. So what do you wanna do? You wanna find the inverse, right? We wanna find the inverse. To find the inverse, which way, 1, 2, 3, which one do you think will be helpful for us to find the inverse? 1, 2, 3, which one? And why? Because you said so. No, tell me the thinking process. X is positive. X is not necessarily positive. Can we bound X in -4 to 0? Well, we need to see that later. Why? We could, but why? Need to think about that. Okay, the reason is when it has absolute value, you cannot get rid of it when you do the inverse directly. There is no way you can do that. Like how would you know how to do that, right? You don't know. Okay, you don't really know. So you need to write it as a piecewise function, and for each piece, maybe you can find your inverse and plug it back in. So I'm gonna start with writing it as a piecewise function. Okay, so my goal is write f of x equals to a piecewise function, but I need more work before I do that. So now, what do you need? We have two absolute values, so we need to get rid of both. So let me copy it here. We have this, so you need to get rid of this, and you need to get rid of this. So now we know that this is equals to x plus 4, when does it equal to x plus 4? When is it positive? If what? If x is greater than or equal to, yeah, exactly. Okay, and it's negative x plus 4 if x is less than negative 4. What about this one? This equals to x if what? If x is greater than or equal to 0. And this is negative x if x is less than 0. So you see that our key points are negative 4 and 0. So I'm going to draw a real number line and see. So let's say this is negative 4, this is 0. Okay, then from here, let's start from the negative side. From here, is this one, do we have x plus 4 or negative x plus 4? Here, which one do we have? Negative x plus 4. Okay, so this means that plus 4 is actually negative x plus 4. What about this one? What about this one? Do we have x or minus x? Minus x, okay. Now, what about in the middle? What do we have? X plus 4 and negative x, okay? So, oops. This is x plus 4, and this is, why did I write negative 4? Oh my god. And negative x. What about the last part? Okay, okay. The last part is x plus 4, and this is x. Okay, so now you can write your piecewise function. So we need to break up into 3 pieces. When x is less than negative 4, you would have negative of x plus 4 over 3 times negative x plus 4. When x is in between 0 and negative 4, negative 4 less than or equal to x less than 0, you would have x plus 4 over 3 times negative x plus 4. And when x is greater than or equal to 0, you would have 1 over 3. Any questions so far? It is clear. My rough work. Meow, okay. Anyone else? Okay, okay. Yeah, makes sense. Okay, so now my question is, which one do we choose? 3 pieces. Which piece do we choose and why? Middle part. Why is the middle part? You're correct, it's the middle part, but why? Why is the middle part the part we want? Why is this piece the one we want? Do you know why? it allows us to solve x. It's not really the reason. What is the reason? What is the reason? Let me give you a hint. It's because of this. So you should find one exactly doing is our y is in between this. So we know that here, okay, at 0, when x is 0, we know that f of 0 is 1/3. When x is -4, what is my f of -4? Someone calculate it. It's 0, isn't it? Do you see? It's 0. So in between this part, okay? In between this part, when x is in between this is where we want. Do you see why now? So this piece will give us our x. Okay, so this is y. Now move on. So now I have can't believe my rough work takes this much space. So now I have y equals to this. And now I can just isolate for x. Okay, so y is, so we pick the middle piece. Y is this. Okay, and now we can isolate for x. So -3xy plus 4y is x plus 4. So x plus 3xy equals to 12y. Am I right? Wait, this is not 4, this is 12. Oh my god. 12y minus 4. So x times 1 plus 3y equals to 12y minus 4, which means x is 12y minus 4 over 1 plus 3y. Okay? So this is going to be my x. And we're done with rough work. We're done with rough work, okay? Let's do the proof. Rough work is done here. Now I need to use my rough work to do my proof. So now, proof. Let's use white to do the proof. And it's the most obvious color here. So proof. Now I can write it. This is why I didn't do an tutorial yesterday, because it's a long question. And I wanna make sure you guys understand what I'm doing. Okay, so claim that. We need to claim because it didn't tell us the image. So claim that the image f of r, which is the image, claim that f of r is from 0 to 1/3. And you do the first inclusion. Okay, first inclusion. Suppose that y is in the image. Then, by definition of image, there exists. Do you guys know there exists single or no? Have you guys heard that? You know that, right? There exists x in my domain, which is R, such that f of x equals to y. Can we use calculus to find the maximum? Well, as long as you don't use calculus in your proof, then you're good. Okay, then y would equals to f of x, which is what we have before, which is this, over 3 plus 12. And I'm gonna write it as absolute value of x plus 4 over 3 times the absolute value of x plus 4. And now I can use my rough work. If you don't remember rough work, you can go back. I remember my rough work. Okay, now you can say by triangle inequality, we know that 0 is less than or equal to absolute value of x plus 4, which is less than or equal to absolute value of x plus absolute value of 4, which is the same as absolute value of x plus 4. Okay, and also we know that since 3 squared absolute value of x plus 12 is positive, we can divide by this on all 3 sides, right? So we have 0 is less than or equal to absolute value of x plus 4 over 3, which I should write it as this, so I can just divide it directly. 3 times absolute value of x plus 4 less than or equal to absolute value of x plus 4 over 3 times absolute value of x plus 4. And this is exactly 1 over 3. Okay, so this is equivalent. My food is here, by the way. I want to eat now. So this is equivalent to y is in between 0 and 1 over 3. So y is an element of the interval. And we know that the image is a subset of the interval. So that's our first direction. Any questions so far? Yeah, this is just the first part. You're right. Yeah, this is just the first part for now. Okay, now let's do the second part. Well, I think as long as you understand the rough work, you should know how to write the proof. Second part, let's finish this question first. And while I let you try the other questions, I can eat. Second part, again, okay, remember how I proved the second part? So now let's suppose y is a subset of the interval. Not subset, it's an element of the interval. Oh my god, I'm actually hungry. My hands are shaking right now. Kind of hard to write now. Okay, so what do we need to show is we need to prove that we have an x, there exists x in real number such that f of x equals to y. So this is what we need to show, what we need to prove. As long as you find your x in real number that satisfies the condition, we know we're done. So from my rough work, I know this is my x. So let's let x be that. So let x be something. What's x again? 12y minus 4 and over something. Over 3y plus 1. Okay. Okay, now tell me, how do I know this is a real number? How can I argue it's a real number? No, I'm saying, how do I know this is a real number? Just based on this. This is my y in. How do I know this? Yes, you need to say this is non-zero. Okay, you need to say this is non-zero. Okay, you need to show it's non-zero, because if it's zero, then it doesn't make any sense. Okay, so since y is in between 0 and 1/3, 3y plus 1 is between 1 and 2. So 3y plus 1 is not 0. Okay, so we're not dividing by 0. And also, since the real number is a field, we know that it's closed under addition, subtraction, and division, or taking multiplicative inverse. So we also can say also R is a field. Okay, we know that X is definitely in R. Okay, so this is to guarantee the X we found is in our dating show. Okay, the X we found is not your mom. It's in the dating show. Okay, now I need to do what? I need to compute f of x equals, I need to let it be y. However, my f of x, where's my f of x? Do I have any? My f of x has lots of absolute value in there, right? So it's kind of hard for us to do this directly because I have absolute value. How can I simplify it with the absolute value in there? So before we do that, before we actually plug it in, I wanna do what? I wanna show my x is in between -4 and 0. Okay, so let's prove that my x is in between this, so I can get rid of my absolute value. So that's why I'm doing this. Okay, remember, I'm trying to show it's in that range so I can get rid of my absolute value. So now, moreover, this part might be slightly harder to follow. Since I'll show you, since y is in between 0 and 1/3, okay, that means what? So again, okay, let me write my x as this, as 4 times 3y minus 1 over 3y plus 1. Okay, so I wanna have something like this or this, so I can divide both sides or do something simple, do something similar to what I did before. So from this, I'm gonna do this, so I can just divide by this later. Okay, so I have 3y minus 1 is gonna be in between 0 and -1, right? So this is what I have. And also, I need to figure out this because I cannot just divide by this. If I divide by this side I'll have a function. This side is okay, but this side I have a function, which is not good. So I'm gonna look for this. This is between 1 and 2. Okay? Now, remember what I need to show. I want to show what? I want to show this is in between -4 and 0. 0 is simple because if you divide both sides by this, you still get 0, so it doesn't really matter. But this one is slightly harder. Okay, so rough work. a simple rough work. It's right in here. I only need a little bit of space. I want to show this. Okay, I want to show this. Now the 4 doesn't really matter. So I'm gonna get rid of the 4 and make it -1. So I just need to show this. Which means what do I need to show? I actually need to show 3y minus 1 is greater than or equal to negative of 3y plus 1. Do you see? So this is what I want to show. Okay? Do you guys get it? That's what I want to show. Which means I actually need negative of this. So I'm going to multiply by -1 on all 3 sides for this one. So that means, that means -1 is greater than or equal to negative of 3y plus 1, which is greater than or equal to -2. Now I have this, I have this. Okay, and I want to show this is less than or equal to this, which is simple. Why? Because this is greater than or equal to -1, but yours is less than or equal to -1. So combine those two, you will get 3y minus 1 is greater than or equal to -3y plus 1 and less than or equal to 0. Did I lose you guys? Are you still following? Are you following, people? You're so lost. Where are you lost? Where exactly are you lost? Just tell me, where are you lost?
Okay, I have a question. So first we have to.
I just realized I'm connecting from and I'm not even using my headphone. Okay, tell me, where are you lost again?
Yeah, I just have a general question about like proving like images and whatever. So for the first part, you have to prove that for f of the domain that that there's a certain range in y, and for the second one, you actually have to prove that there's an x that corresponds to f of each x in that range, right? Like, would you say that's roughly what you have to do?
Yes.
Okay.
We find this from the rough work, remember? We found this from here. But now I need to plug in. So what I'm doing is I want to plug it back in. But f of x has lots of absolute value here, which is hard to get rid of. So that's why I'm trying to show. So this is hard to get this. This is hard. So I'm trying to show x is in between -4 and 0 to get rid of absolute value. Okay? Does that make sense? Can I scroll down? Sure. So this whole part is trying to show my x is in between -4 and 0. I will post the recording. How does it show that? Because I'm not done yet. I'm not done yet. Yeah, I'm not done yet. I'm just asking, does all those steps make sense to you? Are you following? Are you following the inequalities here? Sure. Okay, so from this to this is pretty clear. From this to this, I think it's pretty clear. And from here to here, I just multiplied all 3 sides by -1. Okay. Why did I do that? Because of my rough work. I know that I need negative of this. Okay, so I get this. And it's simple now because From here to here, you just need to multiply by 4 and divide by this, right? Do you see that? So next step is I'm gonna multiply by 4 and divide by 3y plus 1. So this gonna give me negative 4 times 3y plus 1 over 3y plus 1 is less than or equal to 3y minus 1 times 4 over 3y plus 1, which is less than or equal to 0. Okay? How did you get the last inequality? Oh, this is because 3y minus 1 is greater than negative 1, but this is smaller than negative 1. You see? Like here and here. Combine those two. Where did the negative in the middle go? Where negative in the middle? This one? There's no negative because I'm saying this one is greater than or equal to this by combining those two. Do you see? Because think about this. A is greater than or equal to negative 1, and B is smaller than or equal to negative 1, right? So then A is greater than or equal to B. Or let me draw a line, draw a number line here. So let's say this is negative 1, and 3y minus 1 is here, negative 3y plus 1 is here. So from those two inequality, I know this is strictly greater than that, greater than or equal to, right? How do we get the changed inequality from 1 over 3 to 2? Oh, this. So from this to this, you need to multiply by 3 and add 1, right? So you do the same thing for those two sides. So this times 3 and add 1 is 2. This multiplied by 3 plus 1 is 1. Similarly here, it's exactly the same thing. I think you guys just hate inequalities, don't you? I'm a huge fan of inequalities. I really like inequalities. Okay, and we're basically done because this canceled out and this is just negative 4. So from this, I show that my x is in between 0 and negative 4. Do you see? Because, well, x is this. So x is in between that. And we know that when x is in between this, right? When x is in between this, the first, okay, let me just plug it back in. So consider, we reached there. Consider f of x. Now you can plug it back in. That's gonna be, okay, I'm just plugging it back in. Okay, not doing anything hard. Minus 4 over 3y plus 1. And then it's plus 4, right? And then down here, it's 3 times 12y minus 4 over 3y plus 1 and plus 12. So this is, why are you lost? I don't know which part are you lost. Which part exactly are you lost? This is bad because I thought I got you, but you don't get it. Okay, unmute yourself and talk.
Yeah, so now that means that since we proved that x is between -4 and 0, and now you plugged it into the equation, we can just remove the absolute value.
Exactly.
Cool, thanks.
Oh, that means you get it. That means someone understand what's going on. Okay, so because this, okay, is in between -4 and 0, we can get rid of this, right? So this will be positive. So that's gonna be, you can get rid of the absolute value symbol now. So that's just gonna be this. Oops, y. We'll take a break when I eat, and we'll continue after. So I can get rid of the absolute value symbol. And similarly, down here, I can get rid of this as well. And we know that x is less than 0. So whatever is inside, remember this is your x. So whatever is inside should be negative x. So that's going to be -3 times 12y minus 4 over 3y plus 1, and then plus 12. So in this case, you can just simplify it directly because we got rid of the absolute value symbol already. Okay, so continue. That's gonna be, I'll do computation really fast, okay? Because I know you need a break now. And down here, we have, now it's just computation, nothing complicated going on here. Plus 12 plus 36y plus 12 over 3y plus 1. Okay, so those two canceled out. Those two canceled out. Those two canceled out. You're left with what? You're left with only this, and this, right? So that's gonna be 24y over 24, which is y. We're done. You see, we're done. So we found x in real number such that f of x equals to y. Then, by definition of image, y is in the image. Okay, so things, the interval is a subset of image, and they are equal. And we're done. Okay, now let's look at your question. Wait, Desmos doesn't have the domain you found. My domain is not this. My domain is R, remember? My domain is R. My domain is R. My X, okay, my X is in between, sorry, where is my, yeah, my X is in between this range because I picked X to be this. And from my rough work, I know that when X is in this, this is my function. It's because we picked this part. Does that make sense? We picked this part, and that's why your X should be in this, but the domain of the whole function is real numbers. Is image just range? Did we talk about this yesterday? I spent so much time talking about this, and now you're asking me again. Okay, questions. Make sure you understand this first before we move on. After all the questions, I'll go eat and we'll take a break and we'll do the rest later.
I have a question.
Questions.
Is it
Yes.
generally this long for each question? Because I don't understand how we're supposed to do like 3 or 4 of those in like an hour. Because like, wouldn't it take more time?
Well, it's taking us a long time because I'm trying to explain everything. But just doing the question, I think it's like 5 minutes work, isn't it? Okay. For you guys, probably not 5 minutes work. For you guys, probably 10 minutes. I don't think it's that long. But as a quiz question might be too long. As a problem question, it's pretty fair. Five minutes is just rough work. For me, when I do questions, I skip a lot of rough work. Like I won't write all of those. Like if I'm doing rough work, I don't need any of those. I just do those in my brain already. And I only need this part. Like I'm just gonna start from this. So this is all the rough work. So this is all the rough work I need. I don't need any of the other things. I'm writing everything down because I need to show you how it works. Yeah, for me, I'll just start from here and do this and then write my proof directly. And skipping rough work. I mean, you're not being marked by those. Anyway, questions. Again, I'm asking what are your questions? If no question, I'm gonna go eat. We'll take a dinner break. Go eat? Okay. So I'm gonna make it smaller in case you wanna see what's going on. In case you wanna read the whole thing again. And I'm gonna go eat for, hold on a second. Okay, I'll go eat for 10 minutes. And you know what? I'll be back at 6:50. Okay, so at 6:50, I'll be back and we'll continue. The rest of the questions are not long at all. Why can't we pick our x to be in -4, 0? No, I'm picking my x. Okay. Go back to the definition. So go back to the definition. I am choosing, so I might have my y in this interval. Now you just need to find one x. Okay, you just need to find one x that it is in the real number and it satisfies this condition. Okay. So it's like you saw a boy in the image. You want to show this boy is indeed in the image. Okay, so you're tracking back the messages. You found a girl. Okay, you found a girl, and when you use the phones, the girl's phone to send the message, it maps back to Y, maps back to the boy. Yeah, there exists an X that satisfies. Not every single X has to be regularly split. You cannot, there's no way you can do every single X. Like you're using an example, it's impossible because it's real numbers, right? So it's for all, okay, it's for all Y. Where is it? Okay, so you're trying to show for all Y in whatever you found, there exists X in domain such that f of x equals to Y. So as long as you found X in the domain satisfy this condition, you're done. Because that is the definition of image. Okay? And because my Y is picked arbitrarily, so that works for all Y. I'm not picking Y to be a specific thing. It can be any of the number in between 0 and 1/3. Right? I didn't pick it to be a specific number. I'm just saying it could be any of the number in between. So it's for all Y, and it's arbitrary Y. Isn't that every single X in the domain? What do you mean? Okay, you don't have every single X in the domain mapped to the same Y, right? You just need one X in the domain that map to this Y. And because my Y is picked arbitrarily, so for every Y, you have at least one X that maps to it. Yes, you don't have to prove multiple X will map to the same Y. As long as each of the Y has one X, then you're down because that's the definition of the image. So realistically, you can pick any Y and plug it into the inverse formula and get an X back. Any Y in the image. If it's not in the image, then no. Yeah, so for any Y in the image, you should have an X that maps to it because that's the definition of image, right? It's not that hard. It's like a medium level question. It's not that hard. Yeah, it just takes long to explain it too. But doing it itself, it's not really hard. That's why we define X in terms of Y. Yeah, because your X could be anything. Your Y could be anything. So your X could be anything. You just need to make sure it's in the domain. Okay, any more questions? Okay, then I'll be back at 7 o'clock because we took quite a long time to explain the game. I'll be back at 7. You guys take a break. Don't stay here. Take a break, okay? Why do you not know? Did you not talked about it yesterday? I said if you're in my tutorial yesterday, then I'll send you a link of the recording. No, I said I'll send you both. I said I'll send you the link for both. Wait, then how do you know? Then how do you know we are here? That's interesting. From a YouTube? Oh, so you joined like after 5:30? I see, I see. 5 p.m. I let it out at 5 p.m. Huh, didn't know. So you checked my video right after I released it. Okay, thank you. Anyway, let's quickly finish this. I don't want it to be go over like over 3 hours, so let's quickly finish this, okay? Fields. Hopefully, I don't need to go over the 6 axioms. You know all the axioms, right? Meow or bark? Meow, 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 or bark, bark, bark? You definitely should know all those axioms. So I'm not gonna go over them. I just want to mention, besides those, you can also use those. Okay, those you can use them directly. Just refer to as by, claim, blah, blah, blah from the textbook. We know blah, 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 blah. Okay, so those you can use them directly with no problem as well. You can also use whatever is proved in lecture. So what's proved in lecture? Guys, anyone remember what's proved in lecture? Yes, the one that's proved in lecture is this, is negative 1 times a is the same as negative a, right? So this one you can use directly as well. However, I don't want you to I don't want you to misunderstand using this. For example, although you know this, you cannot say, so this is okay, but this is not okay. Let's say a plus b, and you just put this directly in there, plus or plus minus b. You cannot do this directly. Okay. You cannot do this directly. This does not mean you can distribute this inner. It's not what it means. It only means this is the additive inverse of A. That's all it means. You cannot do this. Okay, you cannot distribute it directly. It's not distribution. It's just showing you. So this is just showing you. This is telling you negative A is, sorry, negative 1 times A is the additive inverse of A. Why is negative 1 not in the field? What do you mean? What do you mean why is it not in the field?
I mean, like, why can't you use distribution? Is it because it's not in the field?
Oh, because negative 1 is not really like a number. It's more like the additive inverse of 1. So it's not really -1. It's
Is it?
the additive inverse of 1.
Because
So
in
it's not
distribution,
necessarily -1. It could be 1 itself as well. So sometimes 1 equals to -1. No.
okay. Okay.
Okay. Any other question? How can the additive inverse not be in the field? It is in the field. No, I'm saying you cannot put this in this because negative A is not -1. It's not we're shorten this to this. It's just saying this is the additive inverse of A. So you can do this if you want to. Is you distribute it in, you can do that. That's what you can do. So you can do this. If that's what you guys are talking about, you can do this. Okay, but you cannot do this directly. That's what I'm saying. You cannot do this A plus minus B like this. This you cannot do it directly. Okay. Of course, you cannot skip a single step in fill. Okay, so this is not allowed, but the other you can use distribution for sure. Do you guys remember the proof of this? You don't understand how come AB is 1, then what? I don't understand your question. Kristen, what is your question? Mine, what is the relation between this and AB equals to 1? Oh, this AB equals to 1. Then B is the multiplicative inverse of A. Okay, this is multiplicative inverse. The one we're talking about is additive inverse. This is additive inverse. That's a difference. Does that make sense? So it's different operation. Okay, so recall this a little bit because this is what they always do every semester. They always give you the proof of this. It's different, yeah. They are not the same thing. As a question, yeah. What's the proof of this? Anyone remember? So this is asking to show -1 times A is the additive inverse of A. So what can you do? You can just add this to A and show they equal to 0. Because if they add together and it's 0, then it means that it's the additive inverse of A, right? So add them together. What can we do? This is the same thing like this. And we use distribution. So that's -1 plus 1 times A, which is 0 times A, which is A times 0, which is 0. So I showed that the add together is 0. So it's a additive inverse, or you can just add negative A on both sides. Right, You don't have to do this step, but I just want to show you it's the same as this. So this is negative a times 0 plus 0 equals to negative a. So negative 1 times a equals to negative a. Or you can directly, from here, you can say that directly, this is the additive inverse of a. Or is the additive inverse of a. So, okay, either way should be okay. You can use those two without proof. You can use this without proof as well. I'm just saying the proof itself is quite important. It can be applied to other questions as well. So you can use everything here. You can use here. You can use this. You can use this as well. Okay. But I'm showing you this because I'm telling you the proof itself, the proof technique itself can be used in other questions as well. Oh, okay. So let me erase this and let's do example 3. Let's rate the question and someone tell me how are we gonna do it. Okay, so F is a field, A is an element, A is not 0, and they ask you to find all solutions to x squared plus ax equals to x in F. Yes, you can get the second, of course. Okay, so this is what you need to do. Find solution means you need to find what x is. All right, so give you some time. You have 5 minutes. We'll take it up at 7:15. Try this. Yes, yes. Find solutions means you need to isolate x. So find what your x is. And remember, it's a failed question, so you can only use what's above. So you should not skip any of the step. Okay, don't skip a single step. Yes, you can use that. That's how it's defined. X squared is x times x. That's how I define. You cannot take square root or anything like that. Those are not defined, okay? So there's no square root. Can we say x plus negative x equals to 0? Yeah. That's the definition of additive inverse, right? I just told you we don't have square root. So how are you going to use quadratic formula without square root? Could we do x times x plus a? Well, sure. If you want to do that, sure. Why not? It's distribution, right? Remember this axiom? Where is it? Here. Okay, so I'm gonna take it up. Okay, I'm gonna take it up. So to do this question, again, as I mentioned, we do not have quadratic formula anymore because there is no square root. So to do this, and I need to isolate x. So what I'm gonna do is I'm gonna move this to the side and factor out my x. Does that make sense? So I'm gonna move this to the other side and then factor out my x like this. Okay, so that's my first step, but using filled axioms, it's gonna be much longer than that, but you should know the idea. So I'm gonna start with the original thing, and I'm gonna add negative x on both sides. One thing you need to be careful is whenever you add something or multiply by something, it's either left multiplication or left addition or right addition. So you cannot add something like, for example, I add negative x here, but on this side I add it here. You cannot do that. Okay, so if you want to add either both here or both on this side, you cannot add something in the middle either. Okay, you cannot do that. So I'm gonna add negative x on this side. Okay, so this side will be 0, but this side, we don't know yet. So this side, I'm gonna take out the negative 1 using whatever we proved in lecture. Sorry. So I can factor out x. Okay, so this part, so from here to here, it's because what we proved in lecture. Oops, different color. Sorry. Okay, and now I'm gonna write this as xx and put this out together so I can factor out. So xx plus ax plus negative 1x equals to 0. And this, I can use distributive property and factor out my x. So that's gonna be xx plus a plus -1 x equals to 0. So far, so good. So basically, I'm just trying to factor out my x. Do we have any questions so far? Meow, meow or bark? Okay, we have all meows. Okay, now you have two terms, and we both have x, so you can use distributive property again. So that's gonna give you x plus a plus -1. The whole thing x equals to 0. Yeah, you should say it's from lecture because some TAs they might not know. Because like we all do lecture TA, but some TAs probably missed 1 or 2 lectures every week, so they might not know. So it's better that you mention it so they don't deduct mark from you. You know. Okay. So far so good. Now, okay. So when you reach here, some people would say, oh, that means either this is 0 or this is 0. Do you see that in the axioms? Do we have that in the axioms or did we prove that? No, right? We don't know that. You don't know that. Okay, so you don't know. No, this is saying any element times 0 is 0, but it doesn't mean if this is 0, then A is 0 or B is 0. You don't know this. You do not know this. Okay? Because you don't know, we cannot use that. However, you are right, we do know this. Do you see we do know this? So this is one element. Okay, so this is my y times if x is 0, then it's gonna be 0. This is what we know, right? Do you agree? So what does that mean? That means x equals to 0 is a solution. Why is that? Because y times 0 equals to 0 for all y in the field, right? So here my y is this whole thing times 0 is 0. So it is a solution, okay? But we don't know if this is 0, 0. We don't know, okay? We do not know this. But now x equals to 0 is the solution. And I want to check if there are other solutions. So suppose x is not 0. If x is not 0, then what do we know? Anyone? If x is not 0, then what do I know? No, you don't know. You don't know if y has to be 0. I just told you don't know. I just told you don't know. Okay? What you know is inverse exists. Exactly. X has reciprocals. So x inverse exists. Since it exists, we can multiply both sides by this, right? Look at this. So let's multiply both sides by x inverse. You'll get this. Okay, and this becomes 1, this becomes 0. So that's the next step. So you have x plus a plus -1 times 1 equals to 0. And the next step you have is x plus a plus -1 equals to 0. Okay, so what's my x? Can you tell? What do I need to do next? Anyone? Additive inverse, right? I need to move this to the other side. Exactly. So now let's add that. Add this whole thing. Plus negative of a plus -1 equals to 0 plus negative of a plus -1. Okay? And those two are together. By associative, we can put them together. And this side will just be negative of a plus -1. And this whole thing becomes 0. So x plus 0 equals to negative of a plus -1, which means x equals to negative a plus -1. You see? So I have two solutions for this. One is x equals to 0. 0 and whatever we get here. The solutions are are 0 and negative a plus -1. And we're done. Can you distribute the negative sign? I just told you cannot distribute the negative sign. You cannot do that. Do you need that step with the square brackets? This? Are you talking about this? If I don't have this, then why are you doing this step first instead of doing this step first? On the fourth line, where? One, two, three, four. This? Where exactly are we talking about? This? Oh, I added the additive inverse of this. What's additive inverse? It's negative of something. It's not -1 times something. The additive inverse, remember? Here, we write negative x as the additive inverse. I'm missing the brackets here. I might miss bracket. Let me see. Oh, I should have another bracket here, right? Is that what you're saying? Oh, I see. I probably missed a few brackets. Let me see. Is this one good? No, this one is missing one bracket as well. Where else am I missing brackets? Line 2. Okay, let me see. Oh, here, right? Are we good now? On the right side, line 4. 1, 2, 3, 4. Okay, my bad. Bye. My bad, guys. My bad. Anywhere else? Can I split it into cases? Say one x is 0 and one x is not 0. This is basically what we're doing. So when x is 0, it is a solution. When x is not 0, we got x equals to this. No, it's okay. You should you should be picky about the brackets. I don't understand how x equals to 0. You mean you don't understand how x can be both? Is that what you're saying? Well, that means you might have two solutions for the same equation. Remember quadratic equation, you might have two solutions. Do you remember that? Yeah, so you have two solutions. Does that make sense to you? Why you can have two solutions? Okay. By the way, they are not necessarily distinct. They can be the same. So I'm saying this can be 0 because you don't know if A is not 1. They didn't say A is not 1. It could be 1. You don't know. So if A is 1, then they are the same thing. Does the additive inverse of a part of a field have to be in a field? For every element so here, for every x in F, there exists additive inverse in a F as well. Okay. So every element you have, they should have additive inverse in a field. That's one of the axioms. Any other question? Scroll down to the end. Sure. Here. Where is the additive inverse in 2.3.3? For which element? For 1? I don't remember the table. I think it's 1 plus A equals 2. Wait, 1 plus what is, hold on, let me think. Let me check the table. I don't remember the whole thing, but it should be somewhere. It depends on which element does 1 adding together would give you 0. So it depends. Can't tell yet. Let me think. 1 plus 1 is 0, right? Yeah, 1 plus 1 is 0 in 4-element field. Oh my god, I proved it. So the additive inverse of 1 is 1. Is 1 itself, so 1 equals to -1. Can we draw stuff from it? You can draw, but you cannot use it directly if it's not proved. So you need to prove it first before you use it. So the only things you don't need to prove are this, and this. You should, I'm not saying you should, you could. You could draw it, but it's not gonna be your proof, okay? It can be a rough work, but it's not your proof. It might be helpful sometimes. They're talking about the table I did before, the addition table and multiplication. How do we use it? You're confused. You can use it on multiple choice questions. For example, on your exam, where you have multiple choice questions, and you don't need to prove anything, then you can use it directly. When you are required to write a proof, then you cannot use it. Sudoku, yeah, it is Sudoku. Okay, can I move on to the next one? I'm only gonna do this one. The sets questions are pretty easy. You can do it yourself. I always think sets questions are easy. Okay, so let's read this together. A quick question: how will we prove the given field will have additive inverse or multiplicative identity though? Oh, if you can find, so here, if you can find an element such that this element plus x equals to x for all x, then it means it has an identity. Does that make sense? Yeah, if you can find such element that satisfies the condition, then you call it the identity. So any element plus x equals to x. No, so one element plus x equals to x for all x. So no matter which x you have, it always satisfies, then you can call it the identity. Okay, so yeah, any element in the field, if you add it to any of the elements, you always get x back, then you can call the additive identity. Similarly for multiplicative identity. Okay, move on to this. Let's read it together. The set f is an interval from -1 to 1, where operations are your addition and multiplication of numbers is a field. So they're asking you if this is a field. True or false? False. Why is it false? It is false. Which axioms does it not satisfy? Inverse? Which inverse? Multiplicative inverse. Exactly. So for example, for, let's say, for 1.5 in the set, there is no multiplicative inverse. In F, because the multiplicative inverse is 2, right? 2 is not there. 0 has no multiplicative inverse. Well, that's for multiplicative inverse, it has to be now 0. Part B, for every field F, the only solution, which means it's unique, okay? It's the only one. The only solution to x equals to negative x is x equals to 0. True or false? True or false? False. Why is it false? What other solution can we have? I just mentioned it. Exactly, 1 plus 1 is 0, right? So field was either 2 element or 4 element. 2 or 4 elements satisfy 1 equals to negative 1. Okay. Part C, let f be natural number Cartesian product integer mapped to R be defined by f of ab equals to a plus b. the image of f is all of the integers. True or false? True, it is true. Okay, true. Okay, quickly prove it. Let's quickly prove it. First of all, this is always integer, right? This we can agree. Backwards, you can pick f of a0 equals to a. So for all, sorry, I cannot do that actually, because this will only be natural number. This is not necessarily integer, so I should not do this. So let's do f of 1 and b minus 1. How's that? Which equals to 1 plus b minus 1 equals to b. For all b in integer. Let's just write it like this. For all b in integer, there exists 1b minus 1 in natural number Cartesian product integer, such that that equals to b, and we're done. Okay, so it is true. Yeah, integer plus another integer is an integer. Exactly. Part D is part D true or false? Part D was the one I was gonna prove, but it's not proven. True or false, guys? Come on, part D should be the easiest. Anyone? Why is it true? It is true. Exactly, it's a proposition. Okay, it's a proposition. That's why I said it's the easiest, because it's in the book. It's proposition 2.2.4. And down. Down, down, down. We're gonna stop here. I don't wanna go longer, and I'm pretty sure you don't wanna go longer either. So, do they both have to be subset of A? Well, that's how you define, right? That's your domain. Your X has to be your domain. If they are not subset of A, then they are not in a domain. So don't need to. You really don't need to do that. Some questions with this today, they are definitely harder. Okay, not some question. This question, the absolute value, this question is definitely much harder than a quiz question. So this question definitely much harder than a quiz question, because quiz questions might be a easier version of this, but definitely not this complicated. Why? Oh, it's because 1 plus 1 is 0 in those in 2-element field and 4 elements field. So 1 plus 1 is 0 in 2-element field and 4-element field. 3-element field, it's not 0. 3-element field, 1 plus 1 is not 0. Yeah. 1 plus 1 is A, isn't it? Yeah. 0, 1, A. If 1 plus 1, it's A. Yeah. We just use it without proving. I'm not using it without a proof. For this one, the question didn't ask you to prove it. That's why I did it. But if you want to prove it, it's pretty simple to prove it. just show, for example, use a two-element field. If show 1 + 1 is not 0, then that's it. Then it has to be also 1 + 1 is not 1, then it has to be 0. So suppose 1 + 1 is 1, then you do some step, then 1 equals to 0. This is not possible, so it has to be 0. Yeah, the proof is simple enough that I didn't show it. 6-element field element. You mean 6-element field? 6-element. I don't think it's a field, is it? Hold on, let me think. 5-element is a field. 6-element, it's not a field. Yeah, 6-element is not even a field. It's a group. It's a abelian group, but it's not a field. Sorry, you don't know that. Is there an official definition for De Morgan's law in the textbook? De Morgan's laws that you can use are those two. You can use them directly. They can ask you 5-element field. I don't see why not. I think it was in last semester's quiz. Oh, not quiz. Last semester's midterm or something. Only De Morgan's laws for sets. Well, you can only use De Morgan's laws for sets. You cannot use De Morgan's law for logic yet. Not yet. You're not there yet. Yeah. What's De Morgan's law? This is De Morgan's law here. For logic is when you take negation, which you don't know yet. But sets and logic, they're quite similar. The set identities and logic stuff, they're kind of equivalent in some way, which we don't talk about in this course. If you're interested, we can talk about it some other day, but not today. I'm tired. Okay, let's stop here, and I'll send you a recording when the recording is being processed. I will send it to you even if you are not in my tutorial. So if you're here or you were here yesterday, and then I'll send you the recording. Okay? Okay, let's all leave here. Good luck on your quiz. I'm just eating some Chinese food. I finished my food already. I was too hungry. Bye.